We're gonna go ahead and get started. I'm Debbie Liu. I'm the Associate Director of ESIG, and I wanted to welcome everyone to this special webinar. For those of you who are not familiar with ESIG, we're a membership-based nonprofit organization. We provide our members with objective information, resources, and networking opportunities to support clean energy and energy systems integration decisions. And we do this through workshops, tutorials, webinars, blogs, working groups, and task force activities, and we produce technical resource materials. And today's webinar features the work of one of those task forces, the Grid Planning for Vehicle Electrification Task Force. ESIG also leads one of the pillars of the Global Power System Transformation Consortium, or GPST, whose mission is to bring together key actors to catalyze a rapid, clean energy transition at unprecedented scope and speed. And you can get more information on GPST at www.globalpst.org. So at ESIG, we just completed our fall workshop in San Diego in October. And right now we're planning for our spring workshop, which is going to be in Tucson, Arizona, and that'll be at the end of March. The workshops, the monthly webinars, these are open to anyone. So please feel free to register at any time on the ESIG website at www.esig.energy. You can also find us on LinkedIn, Facebook, Twitter, and videos on YouTube. So a few logistical matters before we get started. Everyone's line is going to be muted for the duration of the webinar to avoid unnecessary distractions. For questions and answers, we're using the Slido platform. And we ask you to ask the questions through Slido at slido.com. So SLIDO.com. And use the event code ESIG18, ESIG18. You'll see a thumbs up button next to the questions that will allow you to cast a vote to help prioritize the questions that are asked. And we're going to save 10 or 15 minutes for Q&A at the end. We'll wrap it up at the top of the hour. Everyone who's on the phone is going to get a link that will be provided once the video file has been posted, and we'll also get short responses to unanswered questions after the webinar. So please don't be afraid to ask your questions through Slido. So today's topic is going to be on how to plan for probably the biggest new load out there since air conditioning. That's electric vehicles. And we certainly anticipate load growth, lots of impacts on the bulk power system, but even larger impacts on the distribution system, where vehicle charging can quickly overwhelm grid edge equipment. So over the last year, the US Department of Energy and Berkeley Labs supported an ESIG task force to bring together industry stakeholders, both from the utility side and from the transportation side, to work on better planning for electric vehicles. And this task force grappled with questions like, how can we better forecast for electric vehicle adoption? How do we understand charging behavior of different types of customers? Can we upgrade the distribution system quickly enough to accommodate EV charging for interstate highways or for commercial shopping areas to handle this new load? How can we plan better when there's a lot of uncertainty? Well, today, we're really pleased, after that year of work, to welcome Sean Morash. He's a power systems consultant, and he's a principal at Telos Energy, and he ran this task force on grid planning for vehicle electrification. Sean, his background's in power systems modeling, T&D planning, technology integration, and over the last 10 years, he's worked on projects that combine disciplines across economics, engineering, technology, and policy. He ran this large, diverse task force with folks from across utilities, ISOs, vehicle manufacturers, charging providers, DER aggregators, and he's going to present on these findings today. So just a short reminder, once again, go to Slido, slido.com, use the event code of ESIG18, ESIG18, to ask your questions. Okay, I'd like to now turn it over to Sean Morash. Sean?
Yeah, thanks, Debbie. Thanks to everybody else for showing up. This week seems like a good week to attend a webinar, and I hope you're able to get a few things out of it. This has been a fun project for me, and we are just about to publish a report, kind of a it's approaching 100 pages of, really getting into the details. I don't quite have 100 pages of content to share, in an hour. I'm not gonna be able to cover everything. So when that does make it public, please take the time to review everything that's in there. I am gonna try to share some nuggets from the task force that, that rose to the top. Before I do so, I want to say thank you to the Department of Energy and to Lawrence Berkeley National Lab for providing some guidance and funding to this effort. To ESIG for generally kind of being who ESIG is and creating a collaborative environment that is really helpful for thinking hard and slow and about some really complicated new things. And then to the task force members, we had, as Debbie mentioned, we had task force folks from across different industries, diverse backgrounds, different opinions. Thank you for allowing me to facilitate some open and honest discussions about different things. So with that, let's go ahead and get into some good content here. So first, hey, we talk about electric vehicles, talk about vehicle electrification. How big of a change is this, right? What are we talking about? And so I've got a couple of charts here that help frame the scale. We've got things in terms of gigawatt hours here for our power systems folks, where we've got our stationary battery storage kind of deployed in the US today is something like 25 gigawatt hours worth of battery storage. If you sum up all the 2 million EVs that are on the road, that's something like 125 gigawatts, 126 gigawatt hours. That trend is going to continue. You fast forward out to 2030, it still looks kind of like a 5-to-1 ratio of storage in EVs relative to storage in kind of dedicated stationary batteries. And this is a big challenge because these are not, perfectly distributed according to grid needs. They're kind of customer-sided purchases. And the demand from one electric vehicle can effectively double the load from a house. And so that's kind of a helpful way to think about it in terms of scale, kind of distributed, but also just large numbers. Let's look a little bit closer at this kind of growth that we're expecting. So we've seen growth, right? Historically, we look at Tesla vehicles delivered over the last decade. We see it's 103% compound annual growth. Okay, this is a exponential curve. And then you fast forward that into kind of, okay, what does it look like over the next decade? Suddenly we go from having, 2 million EVs on the road to something like 30 million EVs on the road, 33 million EVs on the road. And it's kind of, man, those are big numbers. And one of the things that sticks out when we look at these charts and we think through this is the pace at which the kind of Tesla's public charger infrastructure is rolled out has not been as fast as they haven't put as many chargers in place as they have delivered vehicles. There's a variety of reasons for that. We don't need a public charger for every single vehicle, but also there's kind of a lack of sufficient grid infrastructure in some places where they might want to put a charger, but the grid upgrades required to do so are not trivial, right? And so these kind of trends highlight the kind of accelerating demands for grid planning in light of vehicle electrification. I'm not immune to the fact, or I'm not dull to the fact that recently a number of high-profile vehicle manufacturers have backed off of some of their kind of commitments or targets. But if you look at some of their longer-term trends, these kind of the short-term kind of turbulence, I think, is outweighed by some of the longer-term trends. And so the reason I mention that is that, hey, there's like a variety of drivers here that are leading towards this kind of exponential growth, right? Customer demand, vehicle manufacturers, and then public policy are all pointing in a similar direction, right? And so even if there's some turbulence in one of those kind of areas, I think there's enough momentum here to really latch on to the expectation. Okay, so we've got a large volume of vehicles that we're anticipating. But the grid deals in large numbers pretty frequently. So what's the big deal? Well, it's some of the uncertainty here with vehicles that makes them particularly challenging is predicting kind of where charging will take place, but also when folks want to charge, right? How do we plan the grid for a large amount of load when we don't know exactly where it is, exactly when it is. We just know that it's coming somewhere. And that maybe it'll move around, maybe it'll be flexible, but it's still kind of to be determined on some of this stuff. And so we're going to get into each of these in a lot more detail as the webinar progresses. But each of the kind of key points here around adoption, location, and timing of charging has large impacts for kind of how we think about it from a grid planner perspective, but also the costs. So to think a little bit more about costs, we've got a couple of recent studies that were done in California looking at the distribution costs of vehicle electrification and kind of electrification in general. And when you dig into those studies that have been done, one was done by Kavala, one was done by the Public Advocate's Office at the CPUC. You see that they came up with, let's say, very different answers for the amount of distribution upgrades costs that are going to be necessary. These are billion-dollar type investments across the state of California, but they're very different, right? Depending on, hey, if we get one charging profile and one set of assumptions, our distribution investment costs could be 50 billion. Different charging profile, different set of assumptions. Looks like our distribution, costs are going to be about 16 billion over the next couple of decades. I don't think either of these is better than the other. I think they're actually both really high quality work. And it underscores kind of the challenge that we're facing with respect to vehicle electrification. Trying to build a grid that supports an unknown future that balances the risks associated with underbuilding grid, right? Things like we've got, things can be unreliable, there could be stunted public interests, we could have really long wait times for charger installs. On the opposite side, hey, if we overbuild it, right, we would have expensive kind of underutilization. We could be thinking about kind of inequities of costs. Really, it's, we got to find the right balance here between making grid investments on an unknown future, but also with a need to meet the challenge, really. So I don't at all want to say this is all kind of doom and gloom and oh my goodness, what do we do? I'm trying to lay a framework for the grid planners are typically look at these challenges and they don't know where to start, right? And they say, man, this is a lot of unknowns, this is a lot of uncertainty. I'm going to deal with this next year, right? Or I'm going to, we're going to slowly play this out over the course of a couple of IDP cycles or whatever. But I think that lends us to a situation where we are no longer fully kind of, we wind up getting behind pace, right? As the grid is no longer able to keep pace with the vehicles that are kind of wanting to charge. And so, okay, faced with this reality of kind of inaction as like it's not a great path. What are the kind of suggested priority actions to handle vehicle electrification? Well, we had a number of meetings with a variety of folks and came up with 4, but these are all very nuanced. These are kind of, these are the topics that kind of rise to the top. I'm going to walk through each of these in more detail, but generally, we've got to improve our forecasting. There's a whole host of tools that are available that are in various use in certain parts of the country. that are, not used everywhere. We've got smart charging as a tremendously helpful tool that can help kind of alleviate grid constraints in certain areas. It can avoid them in certain areas. It can function as a kind of helpful buffer to help us think through our kind of short-term needs while we realize this longer-term horizon. The third kind of high priority area is for us to incorporate future-ready equipment. We've wrestled with the framing and the phrasing on this topic, but the general concept is to allow for upsizing of infrastructure, allow for upsizing of space, to enable kind of equipment that is suited for the future, that it can support EVs as they show up, right? There's kind of we'll get into more of this, but there's kind of a soft cost associated with any grid infrastructure deployment. And to the extent that, kind of marginal increases in capacity lead to not a significant increase in cost, we want to take advantage of those where we can. And then finally, kind of recognizing that, hey, little changes around the edges are really helpful. That's a good thing. But in certain areas, we're just going to need some proactive upgrades. We're going to really need to get out in front of some charging needs, because those charging needs can grow much faster than utility upgrades can be implemented. This is just kind of the realities of construction. That EV charging plazas, they require very little in terms of infrastructure to construct. It's effectively some plugs and a parking lot in a lot of places. And meanwhile, the grid infrastructure can take a few years to engineer, permit, construct, kind of fully put into place. And so we're going to have to get out in front of some of those. So let's walk through each of those. Improving forecasting. So we're going to do this through a variety of techniques. The biggest thing we want to start with is identifying kind of the key variables of adoption, the use case, and the technology that underpins the vehicles, right? So when we say adoption, this is pretty straightforward. How many vehicles? When do they show up? Tell me about them. The use case is a little bit different, right? This is, hey, what kind of EV is it, right? Is it a school bus? Is it a city bus? Is it a commuter kind of van? Is it I want to say Lyft or Uber driver, right? How are these vehicles being used? Because that ultimately, not every kind of charger not every plug is going to be used the same. Not every vehicle is going to be used the same. And so we've got to, it's not just the adoption. A certain quantity of vehicles could present a large problem, or it could present a relatively small problem depending on how those are used and when they want to charge. So the more kind of use cases we can capture, the more comfortable we can be in our forecasting, right? We can be, we're expecting grid stress to present because of X, Y, and Z, right? Not just because of the broad kind of vehicle electrification. And then finally, we've got our technology track here, where we say, hey, the EVs that are out there today, the batteries in them may change as time grows. Right? When we think back over the last decade, we had smaller EVs, smaller batteries in there, and so the charging profile for those, meant most of them had to charge every time they were used. But increasingly, we've got larger and larger batteries that are capable of spreading their charging needs across a longer time, right? And so thinking through the implications of larger batteries, right, in terms of energy storage in the battery, but also in terms of demand, right? If they want to charge faster and faster and faster, what does that look like? How do we support that across kind of various distribution equipment? So part of the challenge with forecasting in general is the overlay of these different variables and kind of the correlation across variables, where we say, okay, forecast your use case. It's like, man, that sounds fairly complicated, right? I can think of a whole lot of different kinds of EVs. And then we say, okay, forecast where they're going to be. Well, suddenly my problem space expanded a whole lot, right? I said, where are each of my 19 different kinds of electric vehicles going to end up? Well, it kind of depends on a number of things, right? And so part of that correlation is deals with just where our highways are, where our kind of cities are, where our populations are, how kind of the demographics and jobs of different folks in different kind of regions, or even within different service territories of a particular distribution utility, how those kind of progress, right? So what I'm trying to get to here is effectively that, hey, we've got to forecast for our use cases. We've got to take into consideration that we're going to have different types of EVs out there, but then we've also got to kind of think about the implication and locational impacts associated with those different use cases. So the easiest example here is probably kind of heavy duty trucking, or other varieties of trucking, right? Where we say, we know where more or less the trucks are going to go. In port cities, they're going to travel on interstate highways. Maybe they're going to be at truck stops or other large kind of warehouses. They're fairly kind of locationally easy to forecast. And so thinking through kind of location and use case together can be a really helpful tool. Similarly, thinking through timing and location together can be a really helpful tool. And so we've got a few examples here. I think I managed to get 4 different data sources onto one chart, which is all fun and games here, but trying not to confuse, right? We're trying to say that a lot of these different data sources point towards the same things. Okay, so generally, rules of thumb here, your at-home charging happens overnight when folks are home and they plug in. Your in-public charging happens during the daytime when folks are out and about. Okay, that's a fairly straightforward, easy way to kind of conceptualize this. But there's nuance to this, right? Associated with at-home charging. There's kind of different assumptions we could make about, hey, if folks charge as soon as they get home from work or as soon as they get home from whatever their daily activity was, we get a certain charging profile. If instead they're optimized to, hey, make sure you're fully charged before you leave in the morning, right? You get a totally different charging profile that would have different implications for grid planning. Similarly with kind of our public charging infrastructure, where we say, hey, we know folks charge more or less during the daytime when they're out and about, but different plaza locations will have different charging kind of profiles. So if we think about an outlet store, that's going to have some spikes on the weekends when folks are more likely to go shopping, or maybe kind of later in the day when folks, when they're the busiest. And similarly for kind of along interstate highways or in other locations, we've got to think through, okay, how is this particular charging site going to be used in light of kind of traffic patterns, right? They track fairly well with traffic patterns. Some of the early kind of adopters. So we've got to think about our kind of different implications of different locations and what that means for timing. The the example that I really like here that like really makes a lot of sense. Our friends in Eversource up in Massachusetts analyzed some GPS data, and when they did that, they did a number of pretty sophisticated things. But one of them was to look at Cambridge and say, okay, when do folks get into Cambridge, right? Cambridge is where a number of universities are. And what they found was, and there's this big spike in the morning when folks arrive to go to university, but then also kind of the seasonality effect associated with the university schedule, right? So they saw about 10% higher traffic in the winter than they saw in the summer. Then you look at different parts of their service territory and they saw kind of inverse effects, right? Where they said, hey, Cape Cod, it's beautiful out there. We see a lot of folks, traveling there in the summertime. And so kind of understanding your timing and kind of the correlation across timing and location and use cases all help to build towards better kind of understanding and better forecasting of our EV usage. So the other key point that we had here was around smart charging, right? So what I was talking about just now is kind of an unmitigated or kind of free for all charging situation. But there's a number of tools that are, we have in our tool belt for grid planning that allow us to incentivize different types of behavior, or maybe control different types of behavior, depending on grid capabilities. And so we spent a whole lot of time on understanding different types of smart charging, understanding their suitability to address grid constraints or grid challenges at different levels. The key takeaway for me is really around kind of, we've got to rethink what can be accomplished with demand flexibility in the context of electric vehicles, right? These things are much more flexible than a lot of our historical load, right? And so there's a couple of examples of that. I don't really want to read these to you, but I also do. So we saw that, SDG&E observed about 80% of their charging happened off peak when folks were on a time of use rate. Compare that with time of use pilots that were in kind of the 2008 to 2012 timeframe. Folks saw, call it 10%, 2 to 20% peak reduction. Those are kind of very different impacts, right? And then if you look at, okay, Sean, those are different studies. You're comparing a little bit of apples and oranges. There's a UK study that was done recently where we said, hey, they did different programs and isolated kind of the EV chargers, or the folks with EVs and the folks without them. And they saw that the peak demand was reduced by 47% compared to 28% for non-EVs. So all this is to say, hey, we can do, these things are flexible, and we've got to not carry the baggage from historical demand flexibility into our kind of EV demand flexibility. There's a couple of examples I want to highlight here on how we can think through our kind of smart charging capabilities. So the first is in addressing kind of multiple grid needs simultaneously. Okay, so we've got an operational kind of situation, or it's not even operational, but we said, hey, we've got our kind of time of use rate where we're trying to get folks to charge overnight. And the EVs did a really good job. They all started charging right at midnight, and shoot, they overloaded the distribution transformer, right? It exceeded its limit. Well, what if we had folks kind of stagger their charging, right? Instead of everybody starting their charging exactly at midnight, what if they spread out that charging throughout that off-peak period? You can make a case that that can be done, right? It's fairly straightforward to kind of co-optimize across your bulk system power needs to kind of, hey, use power when it's the cheapest, but then also your distribution equipment, transformer capabilities. And we've got to be careful here going too far, because sometimes it's easier to just install a slightly bigger kind of distribution equipment to just make folks' lives a little easier. And so the industry has a little bit more work to do in terms of better evaluating kind of which option is better, right? How smart are we trying to get with our EV charging relative to how much kind of grid infrastructure do we need? But the case that I'm trying to make, and that I think is fairly non-controversial, is around the need to do and evaluate smart charging and kind of evaluate what's possible with these things. One other way that this could show up is kind of around dynamic operating, or maybe dynamic interconnection limits, where we say, hey, yep, your electric bus, you're welcome to charge as long as you only do your charging between midnight and 7 a.m. We can't afford, or we can't give you a full kind of couple of megawatts all hours of the day because of how your neighbors kind of use electricity. It would quickly overwhelm the distribution equipment. But if you start using, hey, just charge when there is capability available, that seems like it's a very kind of most efficient outcome in terms of supporting charging needs, but also kind of with our existing equipment. So there's a term of art, or a term that is catching on in different areas, called automated load management, right? And so what this allows is it's smart charging at the site level. And so you can say, hey, at my kind of point of interconnection, I've got some sort of constraint so that I can, and I want to be able to support a lot of charging, or a lot of nameplate charging beyond this point of interconnection without, making additional infrastructure investments upstream. And so this kind of makes the most sense if we take an example. So the Irish Post, the mail delivery service in Ireland, they're using kind of this automated load management technology. It's part of their charging kind of manager, where they've got 88 kilowatts of supply equipment. So they've got potentially up to 88 kilowatts of charging demand at any one time, but the site interconnection limit is 28.9 kilowatts, right? And so when they start charging, in this example, it's hour ending 19, or kind of hour beginning 19, whatever, it's 7 p.m. Some of the vehicles start charging pretty heavy right away. Some of them say, hey, I don't need to be ready until 3 a.m. or whatever. I can start charging heavy kind of later on after some other folks fill up. So the kind of the net impact here is any one individual can charge, any one individual EV can pull a pretty significant amount of charge, but the aggregate profile kind of stays below that interconnection limit. And so, there's been a fair amount of work done in North America on this. I think our friends who really work on this stuff would say there's more work that should be done in North America. California is assessing kind of how the utilization of this can promote more efficient use of grid infrastructure. It's a helpful thing, basically, just to stagger our charging, to recognize our in-session flexibility of charging, in addition to our kind of between-session flexibility, right? So we can say, hey, with our bigger chargers, or our bigger batteries in our vehicles, we don't need to charge every day. We don't even need to be fully charged every day, right? We can go a few days between charges. Similarly, our in-session flexibility, even when we're charging, there's some flexibility we have in terms of kind of going up and down for how much power we want to consume. Want to be careful with that because there are kind of optimal patterns with your vehicle, kind of for battery maintenance purposes. We also want to talk about kind of this future-ready equipment concept, where we say, hey, when equipment's a candidate for replacement, you can either replace it with the same thing you've continued to do, or you can kind of upgrade that equipment to make sure that it's better prepared for kind of our future where we're expecting electrification. And this is it's a relatively simple concept that gets increasingly complicated the more you learn about it. Okay, so typically these decisions are governed by equipment standards on the distribution system. So each utility will have a kind of set standard that they use that says, hey, this size transformer goes to this many single-family houses or whatever. Those standards are set using a concept around the diversity of load, right? So it says, hey, not everybody's going to use or try to charge their car at the same time. So what's the kind of average impact of an EV that we can use to size our distribution equipment? And so there's this term called our kind of after diversity maximum demand, where we say, hey, after a certain number of chargers, we see that each kind of incremental charger only adds a little bit to the kind of peak demand that we observe on the system. The challenge with this, obviously, is that with the more granular we get on the grid edge equipment, the more our kind of diversity factors diminish, right? So we say, man, not everybody's charging. We know across a couple hundred chargers that each incremental one is not going to make a big difference. But if we're only trying to serve a few chargers with our distribution equipment, the kind of risk associated with a couple of folks charging at the same time, kind of quickly overwhelming the equipment, that increases. Similarly, when we're thinking about kind of equipment standards, diversity of loads, we've got to think back to our smart charging, right? To the extent we're trying to get everybody into the off-peak period or get everybody into kind of when there's a lot of solar on the system, we got to think about, hey, that can be really effective, but is it going to lead us to increasing kind of our distribution equipment costs? The other thing I want to underscore here in this kind of future-ready equipment or future-ready thinking is to take a couple of lessons learned from our behind-the-meter or rooftop PV deployments. So when I think about, hey, what did the industry learn? What did the power industry learn from solar, rooftop solar? We learned a bunch of stuff. One of the things was we really should have some smart inverters out there. And so similarly for EVs, this is there's inverters with EVs. They draw power with power electronics and that kind of define the profiles. And to the extent that we, as grid planners, fail to define the power characteristics that we want, we're going to get some stuff we don't want, right? There's going to be inconsistencies. The load is going to look a little different. That could have some impacts on kind of frequency or voltage at different locations, right? There's been some interesting work that's been done in terms of looking at, hey, if I had a voltage reactive or like a volt-var type charger, would that be able to help our kind of help us from avoiding distribution upgrades? The answer that was modeled was, hey, yeah, it would help a little, but we've got a lot of problems, and this is not the kind of golden egg here. The other thing we got to inherit or take advantage of from behind the meter PV is, hey, we've increasingly developers and kind of the community at large wants to see capacity maps, wants to see queues, wants to see kind of capabilities of the distribution system so they can think through things. The other thing, our kind of final kind of priority area here was around getting proactive. But we want to make sure we're doing this intelligently. Okay, so the case to get proactive comes down to lead time for building electric power equipment. Our friends at National Grid put out what I thought was a really clear, well done white paper on kind of the lead times and realistic kind of distribution feeder analysis that showed, hey, if we've got if we're really taking our kind of New York's medium and heavy duty electrification scenario seriously, this is what kind of load growth looks like. And take a kind of an average feeder, and we realize that very quickly we need to start making decisions today to meet that heavy duty load growth. And so the case here is around kind of, hey, we know we've got to get proactive. There's kind of some uncertainty, but we're still stuck in this kind of world where there's risks on either side of underbuilding or overbuilding or misbuilding or not doing it quite right. And so we've got a couple of examples of all right, if we're going to get proactive, how do we do that? One of the things is around kind of short-term solutions or kind of adaptability of the decisions we're making today. So Southern Cal Edison is looking at, or really is installing a variety of 1 megawatt, 4 megawatt hour batteries to support their kind of targeted vehicle electrification growth. So we want to make improvements that will be helpful to meet our kind of short-term pinches, short-term needs, but also will stay useful over kind of a longer horizon. Batteries are going to stay useful for a while. But the other thing here around kind of proactive upgrades is around managing kind of multi-stakeholder input. That the more folks we have looking at the problem, the more groups that we have kind of investigating things, the better off we'll be. Grid planners can plan a lot of things in isolation, but community folks, regional kind of transportation networks can be done with kind of multi-stakeholder input, and that'll help us de-risk some of the investment decisions. So I've walked through a variety of kind of practice, like in practice, what do we want folks to do? Get real granular in forecasting, really take a hard look at smart charging more than you have kind of in the last while. I want you to think about kind of, hey, reevaluate your equipment standards in light of vehicle electrification. And then really think through kind of your proactive kind of targeted system upgrades. And so those 4 things are really important. And we've got this kind of overarching goal that, hey, we've got all these long-term studies that show, hey, we're going to need X billions of dollars of distribution equipment, but we're having a hard time translating those kind of long-term studies into short and medium-term kind of action plans, right? And so we've presented a few ways that can be done around kind of, hey, your kind of future-ready equipment can be made as part of those kind of X billions, hopefully making it kind of more affordable. You can be better at targeting system upgrades if you're better at forecasting. And then we can kind of have a plan, we can learn from our behind the meter, our rooftop PV for interconnection plans. But the other thing that we want to kind of highlight here is around, hey, it's not just these like practices, it's not all in the grid planner to design the perfect grid. We've got to think through our processes holistically to enable kind of the most effective grid plan. And so this to me was a really key kind of outcome from this effort, was around the capability of our existing processes to handle a variety of kind of use cases, and kind of what our existing processes look like in terms of annual system reviews, in terms of kind of regular kind of horizons. But then we want to introduce the need for kind of customer collaborative processes and these kind of multi-stakeholder processes. So this, to me, the multi-stakeholder, that's being done in some places. It's been talked about a variety of times. Some places you might even say, hey, we already do that. That's awesome. I think keep that up, use it to support different goals. Use it to kind of de-risk and provide the clear roadmaps for electrification planning. The thing that's a little different is around this customer collaborative process where we say, hey, charger, fleet customer, we want you, hey utility, we want, X megawatts of charging. The utility studies that and says, hey, X megawatts is going to be tough, but what if, you did something a little different, right? And kind of working together to find the solution that makes the most sense, right? To evaluate multiple options for interconnection. So this is kind of, hey, if we gave you if you were allowed to be energized for certain hours of the day, would that support your business use? Or hey, you could avoid X millions of dollars of upgrades if you moved, your charging needs to a slightly different location. So we've got, the white paper spends a lot more time on this, is hopefully a lot more eloquent than I just was, in explaining what these different processes are, how they're a little different than what we do today. But the way that it comes home for me the best is in thinking through, okay, when would I use these different processes, right? So I've got 4 examples of kind of types of charging or charging needs that may be required, and we say, hey, we can use each of these processes to support kind of everything, right? We can, if I'm trying to do charging along highways, I can do that with our existing processes as long as there's minimal highway usage, right? Or, hey, if I'm trying to support charging in kind of vehicle fleets, the best way that's going to be done is with this kind of customer collaborative process, with this back and forth, where we identify the grid solutions and also the charging solutions that make the most sense to support the business need at the most affordable price. And so, there's cases to be made that, hey, we can do an awful lot with our existing processes, and that's totally true. But we've got to be aligned on what all we're trying to enable from a grid planning perspective. If we're really trying to kind of do a lot of vehicle electrification, we've got to think about the different types of processes that may be required to enable that. And so, I want to finish on kind of a wrap up around kind of our summary and key points here. We've got a lot of uncertainty, but decisions are needed today. There's opportunities here to improve our forecasting. There's opportunities to shape perception from like a grid perspective on how much we can do this, how much we can support things. Smart charging is going to be really helpful. We've got to reevaluate a lot of our demand management practices in terms of enabling flexibility both across charging sessions, but also kind of within charging sessions. We got to do that if we're going to use it to, make investment decisions on infrastructure. If we're going to use it in the long term, we've got to get smarter about smart charging. And hopefully we can do that in the short term, so that we can continue to do things long term. And then our kind of the last key point here is that hey, a lot of these planning improvements are outside of our normal processes, our normal activities. We don't want to totally disrupt the things that grid planners have been doing. But there are areas where they can be improved, right? We can reconsider our design standards, reevaluate what those look like. We can make cases for kind of proactive upgrades, even though we're not totally sure about kind of how things are going to shape out. We can expand our planning horizon to kind of capture these different growth curves that may be outside of our current kind of horizon period that we typically look at for distribution planning. And then, ultimately we've got to think through making sure that the grid is capable of supporting this electrified future. It's a big opportunity, right? We've got load growth on the system for the first time in a while, but hopefully we're able to meet the challenge through kind of thoughtful planning, making some changes to what we do, kind of starting from where we are today. I think it's possible to see a future where the grid supports a high level of vehicles charging kind of whenever they want. So with that, I will open it up to questions. Last thought here is thank you to everybody for listening in, and thank you to the task force for all the input on this stuff.
Thank you so much, Sean, for this great presentation. It's really hard to cover a 100-page report in 40 minutes. And so I encourage folks to download the report when it's available, which should be in the next couple weeks. And you'll be able to delve into the different examples and sort of good, better, best practices on each of the topics. So Sean, we've got a lot of questions. Let's just get right into it because there's a lot here. The first one's from Christian Savdari from VTU in Denmark. And Christian says, our investigation in Norway and Denmark does not suggest that smart charging is a silver bullet. Do you have any thoughts on how you mitigate avalanche or synchronization effects?
Avalanche is a new effect for me.
Oh, okay. So I think what they're talking about is when, if you line up, it's sort of like what you were saying about the after demand diversity, maximum demand stuff. If you try to line up all of your charging at the same time, everything is synchronized, and then you've got these huge spikes in demand.
Yeah. I mean, I'm trying to draw a line here between, I also don't think smart charging is a silver bullet. We're gonna need more infrastructure, right? I think that's a key point that's shining through, to enable the deep electrification that we've talked about. But it's also hard to deny that smart charging is helpful in a lot of regards, and that there are tools and there have been studies done that have kind of avoided some of these over synchronization where hey, everybody starts charging right at midnight when the signal goes out. That's what I said. I think we've got to get smarter about smart charging, where it's really helpful, but it's not. I don't think it is a silver bullet.
Sure, and I just remember, there was discussions we had on, like there were some crude ways of doing it, which is say to eliminate the rebound effect, you limit how much charging happens in, the first short period to 50% and then let it go to 100% just to help with the ramps on the grid side.
Yeah.
Things like that. So next question, do you know which utilities are doing the best job forecasting EV adoption and charging location and timing? And they also want to know what kind of software or models they're using.
Yeah, we in the report we've got a good, better, best section. Where we talk about forecasting and we highlight some utilities that are doing some really innovative things. I mentioned in this presentation Portland, Southern Cal Edison, Eversource. I don't know if I mentioned by name Encore, but they're the other one that I would give a big shout out to in terms of thinking hard about medium and heavy duty electrification and the best way to get the best data on that stuff. What tools are they using? It's a variety of tools. I think a lot of them are advanced kind of in-house tools that they're patching data from different networks together to come up with the best forecast that they can.
Great, thanks. Is there real-time visibility on the local distribution transformer loading typically? Or does that require a special monitor to do? So real-time visibility on transformer loading.
I don't have a stat off the top of my head. I would say it's fairly rare to have local distribution transformer real-time monitoring. You can get there through your advanced metering infrastructure, where you can, assuming you've got good mapping to your distribution equipment. Rule of thumb on how many folks in the US have AMI is, I think it's 60% now have advanced metering. One of the thing that I don't want to say, hey, we need real-time visibility into our distribution transformer loading. I think it's a little bit the opposite, is we need to make, because we don't have real-time visibility into that loading, we've got to rethink, are we accidentally going to burn up a lot of equipment when we plug in electric vehicles? We've got to think about that in the kind of planning realm, because it's not something that's easily accomplished in the operational kind of real-time realm.
Another question is, how do you see the penetration of electrification of vehicles across like light duty, medium duty, heavy duty? Like how fast do you think these different sectors will electrify?
Depends on the region, right? That's what the case I was trying to make in one of the slides was around, hey, we've got our adoption forecasts, but they depend on the use case, right? The kind of medium or heavy duty or light duty. Then they also depend on the kind of location, right? The different areas within a service territory have different kind of adoption rates. Try to answer the question. I think light duty vehicles are going to kind of electrify before medium and heavy duty, but medium and heavy duty will happen really quickly, particularly for certain use cases, right? So we think about drayage, where the trucks are pulling things out of ports. It's a perfect use case for electrification where they've got kind of the same driving pattern every day. And the kind of turnover models for medium and heavy duty trucks are pretty quick. So as soon as that makes financial sense, it'll happen pretty quickly.
Sure, that makes sense. This is a little bit of a comment. I imagine the future of EVs as a car sharing concept. Not everyone would have an EV. I don't foresee a 1-to-1 ratio, not enough minerals in the earth. I think maybe what they're commenting on is, did you look at the possibility of car sharing or?
Yeah, we comment on that in the full body of the report. It's something that we really dealt with in the task force setting, where we said, what do we do about this? And the overwhelming feedback I got from a variety of different folks was, Sean, we've got so many challenges in the near and medium term, like that the long-term future of EVs is it's like a distraction, that we've got to make a lot of progress now. And if and when kind of car sharing and autonomous vehicles becomes a reality, we can begin to adapt. So that's my comment on that.
Sure. How do you see the impact of energy storage systems, BESS, in the grid planning activities for electric vehicles? So maybe kind of like what you said about SoCal Edison and their battery systems, I think. I think that's what they mean.
Yeah. I mean, the concept of, I guess, like the engineer in me doesn't like the idea of charging a battery from a battery because of the energy losses that we run into with that. But the reality is, sometimes it's the best option. Sometimes we've got enough energy, and the problem is the infrastructure to get it to where it needs to go. And so I think there's a real role for energy storage systems on the distribution side, but also on the site side, where we could say, hey, to enable some of this smart charging from the kind of utility perspective, it's fairly easy for a site charge point operator to, fairly easy. It'd be easy to pull off, if you've got a battery sitting there. Doesn't make it necessarily more expensive for the site, but it may in some places be a really helpful solution.
Sean, I realize it's the top of the hour. There's still people on the phone, and there's a lot more questions.
Right.
We have a couple more minutes. We go through a few more, or should we?
Let's do it. Let's do a few more.
Okay, let's do a few more.
I'm on a roll. I don't know.
Let's see. How does the SoCal Edison batteries help with medium voltage feeder or transformer overloading? Where on the distribution line are they located?
You have to ask SCE where exactly they're located. What I understand is a lot of them are going at the substation level to help with the substation overloading. It's a good question that, hey, could some of these be deployed, hey, the middle of the feeder or potentially at the end of the feeder where maybe we've got some voltage challenges going on. I think it's an area for optimization. I think knowing SCE, they've got thoughts on it. And I want to be careful not to speak for them on kind of where their deployments are going.
Okay. Have you identified how distribution utilities will have to adapt in their business models?
I don't think we talked about that. Did we talk about that, Debbie?
Yeah, I don't really think we've talked about that so much.
Yeah.
I
mean, with respect to proactive investments and kind of regulatory reform, we've spent a fair amount of time on that general topic about how do we align investment decisions with efficacy, right? So are we gonna put some stuff out there that rarely gets used, and how do we think through if that's, maybe it rarely gets used at the beginning, but longer term it's going to be used fairly heavily. Or, hey, as we get more and more to sophisticated rates, what does that mean for, rate recovery and kind of tracking all the revenue that happens in the distribution utility business model? I think these are challenges that pop up even for munis and co-ops, right? I don't think this is like a business model challenge. I think it's a distribution planning challenge.
Okay. Someone asked if you're familiar with any entities that are pursuing market-based approaches for allocation of constrained assets. So bidding for access. So sort of more a distribution, maybe transactive model.
I'll answer with something I'm familiar with, and I don't think it necessarily answers their question. Hawaiian Electric proposed what I thought was a pretty interesting application, where they've got a system in place where they're trying to, or they don't have the system in place. They're trying to effectively establish queues for distribution locations. So they say, hey, if you want, if you're telling me, you're going to build a high rise or a charging plaza, I'll plan for that, but if you really want me to plan for it on the timeline that you're talking about, put forward a certain amount of money to hold your spot in line, hold your distribution capacity. If and when you show up, yep, you get rate just like anybody else would, and we'll give you bill credits to pay you back for your down payment, basically. And I thought that was a pretty innovative way to deal with kind of weed through some of the noise that can pop up on the distribution equipment from local folks. So it's less bid for access and more kind of reserve your spot in line, more like up the ante for queue positioning. Make sure that the folks who are asking for service, really want it.
Great, thanks, Sean. It's about 5 minutes after. I think maybe we should wrap it up now.
Let's do it.
Sean, I just want to thank you again for your leadership in the task force, for the presentation today. As I mentioned earlier, an email is going to go out once the video file's been posted, and we'll answer the questions we didn't get them posted as quickly as possible. We really appreciate everyone's engagement. Look forward to seeing you again, maybe at our spring workshop in March 25th in Tucson, or tomorrow's joint ESIG GPST webinar that's from Jun Boom Kwan, EnergyNet, on developing an EMT study and analysis environment for a 100% inverter-based power system. Further information on all our webinars and meetings can be found on our website at www.esig.energy. You're all invited to attend. Sean, thanks again for this very informative webinar. Thanks to all the participants for your interest and the questions, and happy holidays to everyone. Thanks.